straightforward because you have the equation and you have the necessary values there. It should be a 3D. So you have to expand your analysis to 3D wherein one stress is equal to 0. Two stresses actually, sigma 2, sigma 3 are both zeros. Okay, if you move to question 2, what is your assumption? So please proceed with this one, and probably you can have your assumption here. So what's your assumption? Plate stress, plate strain. Plate stress is when you have one to be thinner than the other two sides. Thick is when you have one side to be much thicker than the other two sides. You only have a so here if you have a plate, so if you have this plate here, then normally you will probably assume that this one will be a plate stress. But if you have this condition wherein one is much longer than the other two sides, this and that, and this one will be much thicker, then you have a plate strain condition. So with this assumption, then you will now be able to solve question number 2. So let's see what you got. So once you have already determined your stress tensor, then you can simply use your constitutive equation. Stress equal to this stiffness matrix multiplied by your strain tensor. So this will be dependent on your assumption. Since this one is 2D, this can be a 3x3 matrix, this one is a 3x3 matrix, and similarly this will be a 3x3 matrix. Meaning 3x3 matrix, this will be sigma 1, 1, sigma 2, 2, sigma 1, 2. And then you have your 3x3 stiffness matrix. You have an equation there. And then you have this one to be epsilon 1, 1. Epsilon 2 to epsilon 1, 2. So this will be very much dependent on your assumption. Oh, sorry, I didn't mention here modulus. Let's assume a modulus here. So your E, what's the modulus of steel? 200 times 10 to the 9. Keeping 8. Pascal. Okay, 200 or 2 times 10 to the 9? times 10 to the 9. What about your Poisson's ratio? Yeah. So normally this value here will be about 0.25, 0.3. So normally you don't really get any mistakes here. The reason is the difference is too small. Unless of course you're looking at polymers, then you really will have difference here. But if you're looking at metals, you won't really have a huge discrepancy in this Poisson's ratio. So you can, if you have a steel or any iron or something, you can just assume 0.25 to 0.3. That will do. Okay, so please continue with that. Determine your strain tensor.